Okay, so we're going to go ahead and work on homework 3. So this is this weird situation of we've got two piezometers one coming out of gasoline and one coming out of glycerin. I'm going to go ahead and work this one on this sheet only because it's going to be easier for me to kind of work with this drawing if I can just work directly on it. Okay, important things to note is the gasoline is the specific gravities here of 0.7 and 1.2. Okay, so the gasoline S is 0.7 and the glycerin S is 1.2. Okay, and the reason we know, I didn't tell you which was which here. However, this one is more dense because it has a larger specific gravity, so we knew that one had to be on the bottom. Okay, the pressure at A, this is 200 kPa right here. So we want to determine the difference in, sorry, I'm dog sitting here and they're barking. So what we're looking for here is we're looking for this difference in heights right here. Okay, whatever that might be. Determine the difference in liquid pressures. Okay, so that's A, and then B, what happens if A goes up to 400 kPa. So when I assigned this, I imagined that the pressure at A wasn't going to affect that difference, but let's go ahead and see if that's in fact the case. So what I tried to do here is, and I'm going to kind of walk you through what I thought would be the easy way to do this, and let's see what happens with that. Okay, so I'm going to label some things before I begin because I think that this is just a good policy. Well, it's not necessarily, in this case, I think it's going to be helpful. Okay, so here, this right here, that distance, I'm going to call that ZB. I'm going to call this distance right here Z sub C. Okay, so this little blue line, the thing we're looking for, that's ZB minus ZC. Okay, or ZB minus ZC, or maybe delta Z if you wanted, but I don't know. Okay, so I'm going to show you what I first tried, is I thought I'm going to go directly from B right here to C. And I think I can, just solve this sucker straight up. So I said, okay, I'm just going to do a pressure equation. So the pressure at B. And then what I'm going to do is I'm going to just kind of start walking downwards. And so I'm going to walk down to here. So that's some distance. And I'm going to walk all the way to the bottom of the gasoline in one fell swoop. So what is that distance? Well, that distance, so I'm going downwards. So it's a plus sign. And I'm moving through gasoline, so that's gamma, let's call that G for gasoline. And for the glycerin, we'll give it a Y, okay? So anyway, so I'm going downwards through the gasoline, so that gives me a plus sign. And then because it's gasoline, I got gamma G. And then how far did I go? Well, I went ZB, but I didn't go all the way. I stopped 1 meter short, right? So minus 1 meter of all the way, okay? So now I'm in glycerin. So now I'm going to go from here to here, and that I'm going lateral in a fluid, so it doesn't matter. So now I'm going to go back up. Okay, so I'm going to give that a minus sign, gamma of the glycerin. So there's a Y sign right there. And how far up did we go? Well, in this case, it looks like we went up ZC. Right, but I didn't start at 0. I started at 1. So we're going to go minus 1 meters. Okay, and that's going to get me to this point right here, which has a pressure of C. Okay, so that looks like really nice and pretty. Like, okay, cool. So because I've got my ZB in here and my ZC here, all I need to do is rearrange this equation to give me ZB minus ZC. And I should be all ready to go, okay? And so the first thing I'm going to do is I'm going to make PB and PC. Those are going to go away because they're atmospheric. Atmospheric. Okay, I'm going to zoom in here so that we can look at it. Okay, for gamma of the gasoline, I'm going to change that to SG times the gamma of water. ZB minus 1 meter. For gamma of the glycerin, notice I'm moving it over to the other side of the equation. I've got S of the glycerin times the gamma of water times ZC minus 1 meter. Okay, so this is, really shaping up nice for us. Okay, so now maybe I think it's probably a good time to start plugging in some numbers, right? And And this is where things get a little interesting. Right, so Sg, that's the lighter fluid, 0.7 Zb minus 1 meter, equals Sy, which is going to be 1.2 Zc minus 1 meter. Okay, and I keep going, so we get 0.7 Zb minus 0.7 meters equals 1.2 Zc minus 1.2 meters. Okay, so 0.7 Zb equals 1.2 Zc, let's see here, minus 0.5 meters. Okay, and so if you get here, you can see that algebraically it's going to be very difficult. Okay, maybe even probably impossible to get Zb minus Zc. Okay, and there's a reason for that. Is that, you know, the reaction to the pressure at A is different between these two liquids because of the different densities. So a very low density fluid is going to rise higher in its tube, and a very high density fluid is going to, you know, rise less high. So somewhere within here, we've lost track of the fact that this is, you know, this is a function of the pressure at A. Okay, so that's one of the reasons why we can't get just a nice clean answer here. So instead, we're going to have to do this a little bit of a longer way, which I think is okay, especially because it allows for more example here. And so we're going to do what we just did, but we're going to do it twice, okay? And you could probably use that equation that we just did as one of your two equations. It would be totally fine. But let's go ahead and let's just walk from A down to B. Okay, so we're going to start at A. Okay, PA. Okay, moving downwards through the air. So we're not interested in that. Doesn't matter. Okay, because air is so light. Okay, and now we're going to move into the gasoline. And, well, we're going to go down in the gasoline, but then we're going to end up coming back up in the gasoline. So basically, we're moving sideways in the gasoline, so we don't worry about that either. Okay, this is the only bit that we're worried about. Okay, so we're going to go upwards in the gasoline, gamma gasoline. And what is that distance? Well, that is going to be, well, let's see, this was Zc, and this right here is 2.5 meters. Right, so this is going to be Zc minus 2.5 meters. Okay, and that's going to give me the pressure at B. Okay, so that's one equation. Okay, and it's got one of the things we're looking for here, which is Zc. And we can get rid of PB because we can say, oh, well, this is atmospheric, so we use gauge pressures. So right there, we're making an assumption that this is gauge, okay, which I hope seems reasonable to you. Okay. So then we'll go over here, and I'll get, let's do this for the second part. So PA, okay, now I'm going to do the same thing, but I'm going to go to C, okay? So we're going to go down to here, okay? Don't care about that because it doesn't matter, because it's air. And then we're going to go from that point down to the bottom of the gasoline. So we're going to add gamma G times that distance, which is 1.5 meters. Okay, and then we're going to go into the glycerin. Okay, so again, we're going to go down and then over and then back up, so we don't worry about this movement to here, right? So we're only going to go upwards, minus gamma y. Okay, now what is this distance right here that we're going up? Well, that's Zc. Oh, geez. Okay, sorry, this was a B here, wasn't it? Okay, so this should be a B. So this would be Zc minus that 1 meter. Okay. Zc minus that 1 meter. Okay. And that's going to get us all the way up to here. Okay, equals the pressure at C. Okay, and again, the pressure at C is atmospheric, so we can kind of like move on from there. Okay. Okay, note that at this point, if I combined these two equations, I would get this equation. Okay. Anyway, so what we're going to do now is we're going to solve these. And solving these is not... hold on, I got a little bug. An actual bug, not a computer bug. Anyway, so PA is 200. Now, because it's KPA, it can be helpful to write it like this, okay, because that will help you not, screw up your units. I'm going to move this whole term over to the other side, so it'll be a positive. So instead of gamma G, I'm going to write S of G, so that's 0.7 times the gamma of water, which is 9810 newtons per meter cubed. Okay, and then I've got ZB minus 2.5 meters. Okay, so if I plug all this in and do the algebra, I get ZB equals 31.625 meters. Okay, over here on the left hand, on the right equation. Okay, let's see. So PA is 200,000 newtons per meter squared. Did I do squared? I did squared over there. Okay, plus gamma G. Okay, so gamma G is, remember, that's going to be SG. So the SG is 0.7. Okay, times 9810 newtons per meter cubed. Okay, so that's the gamma G. Multiply that by 1.5 meters. Okay, minus, now we'll do the same thing for the gamma Y. We'll expand it into 1.2 times 9810 newtons per meter cubed. Okay, and then we've got ZC minus 1 meter equals 0. Okay, kind of an annoying equation, but nothing you can't handle. And so we're going to end up with ZC equals 18.864 meters. Okay. If we combine these two, basically we subtract one from the other, we can get ZB minus ZC, and we get 12.761 meters, or, since I prefer 3 sig figs, 12.8 meters. Okay, so then the question becomes, what happens if we double the pressure in this particular equation? Okay, so if instead of having 20,000 kilopascals, we had 40,000. So this is just, 400,000. Okay, so this becomes 400,000. Okay? And the temptation would be that there shouldn't be a difference. However, this gas is very light. Okay, so it's going to respond, it's going to have a bigger response to changes in pressure than glycerin, which is, it's, like 1.5 times as heavy. Okay, so it should have, 2/3 as large of a response. Okay, so if we go down here and we do the algebra here, so if I just redo these equations, okay, I'm going to get different numbers. So I get these numbers right here. Okay. And if I plug them in down here, then I get Z, well, I guess I could do it right here. ZB minus ZC equals, okay, something like that. And then I could say, well, in this case, ZB minus ZC equals 24.9 meters. Okay, so if in this case we doubled the pressure, and we almost doubled the difference in the piezometers. Now, I will note that what would be interesting, of course, is if the atmospheric pressure went to 0. What would happen in that case? I guess I could solve that, but that's kind of uninteresting. Or not atmospheric pressure, if the pressure at A went to 0. I guess this situation would be a little bit weird. Not really sure what would happen there. Let me see, just because I'm curious. So if this were 0, then ZB would end up being, would be 0. That would make sense. So basically, this would be right at that level, right, as it would have to be. And if that were the case, then ZC would be whatever this is right here, right? Because this would go to 0. And ZC would rise a little? That's weird. Huh. Very interesting. Huh. It would rise by whatever the ratio of 1/2 to 1.2 is. Anyway, my dog is barking. I gotta go. Anyway, I hope this was helpful. Just something to think about. Okay, think on it. All right.